Here we have a problem involving an electronic device that consumes 25 watts of energy. The weight of the device is given, heat capacity is given, and we are told that the device is operated for 5 minutes. Starting temperature is 25 degrees Celsius and we are asked to calculate the final temperature. In the second part of the question, we are asked to calculate the final temperature considering that the device is connected to a heat sink that weighs 0.5 kilograms and the heat sink is made out of aluminium. We are told that the heat sink is isothermal with the device. That means the temperature of the device and the temperature of the heat sink can be assumed to be same. Now let's develop a plan to attack this problem. Since we are asked to calculate the temperature, and we know that the energy input to the device, we can assume that we have to do an energy balance to this problem. Generally, for most of the thermodynamic problems, you can start the problem with an energy balance. When we write an energy balance, we can see that the energy input to the system is work electrical input. Since we are calculating the maximum final temperature, we can consider energy output is equal to 0. Change of the energy of the system or the device can be written as M delta U, and in this case delta U is equal to C delta T. C is the heat capacity of the device, 850 joules per kilogram degrees Celsius. For the second part, we can do the same energy balance equation, but in this case, when we are considering a change of energy, we have to consider the change of the energy of the device and change of the energy of the heat sink. Change of the energy of the device can be written as before. When it comes to change of the energy of the heat sink, we have mass of the heat sink, heat capacity of the heat sink, and change of the temperature of the heat sink. Heat capacity of aluminium is not given. We have to find it from table A3. Table A3 lists heat capacities for many different substances and materials. So you can get the heat capacity of aluminium from table A3. Now let's solve this problem. We are writing the energy balance to the chip. We know WEin is equal to delta U device. We can write WEin as W dot EIN into delta T. So delta T is the time period. We use W dot EIN because we are given the power consumption of the device in watts. We know that watts is joules per second. So 25 watt means energy consumption per second. Now we can substitute suitable values for these variables and we can get the T2 value to be 466 degrees Celsius. When we are considering the heat sink, we can write energy input to the device is equal to change of energy for the device plus change of energy to the heat sink. Let's consider temperature of the device and the heat sink at the end of the process as T2 dash. When you substitute suitable values for this equation, you can get the final temperature, which is 41.0 degrees Celsius.